In this lecture, we'll be reviewing some of the energy considerations relative to nutrition that you need to have right in your pocket for your medical licensure exams. These things include basal metabolic rate, as well as body mass index, total energy expenditure, as well as the fuel caloric values and so forth. So moving into looking at basal metabolic rate, most often we'll consider resting metabolic rate because it's a much more simple measurement to make. Resting metabolic rate doesn't take into account having to have 12 hours of fasting and necessitate 8 hours of sleep. It's a simple measurement taken upon waking and getting up. So resting metabolic rate is generally we use an equation to calculate our basal metabolic rate, but if we are going to do it very clinically, we would measure the VO2 at various times on various days. But again, we will generally use an equation to calculate basal metabolic rate. And I'll introduce you to or help you review two of them that will be important for you to keep in mind. This first one, you probably just need to know the name of, but if you want to go beyond that, you could memorize the equation. We're not going to spend time deriving it, but it takes into account the age of the individual as well as the gender, weight, and height. And you can see that there's an adjustment over there on the right-hand side based on the gender, whether it's male or female. And again, you don't need to understand where the numbers come from. It's a plug and chug kind of thing, measuring height in centimeters and weight in kilograms. More commonly these days, though, the Catch-McCardle formula is utilized, in which we consider pretty standard numbers. Basal metabolic rate equals 370 plus 21.6 times the lean mass in kilograms. The catch here is that we have to know the body fat percentage, and that turns out to be not so difficult to ascertain these days. Of course, you can do caliper testing, but there are bioelectric impedance devices that a patient can just hold on to, and we get a fairly decent estimate, or at least relative estimate, of the body fat percentage. So we can calculate lean mass by subtracting the body fat percentage. So Catch-McCardle is the one I would certainly commit to memory and keep in your pocket for use on your exam. Now, total energy expenditure is the energy we use beyond our basal metabolic requirements, plus all the other things that we do in a day. So all our caloric needs over a 24-hour period. First of all, you probably realize, but maybe haven't thought about it in the total energy expenditure realm, that when we consume food, it actually costs us calories to consume and digest that food. So that is the thermic effect of feeding, and that's about 10% of our total energy expenditure in a day. Now, of course, in addition to that, we have some physical activity. Some of that physical activity is activity that we choose to do as we move around, but even when we are sitting still, we are still burning calories. And we need to add this physical activity, whether it's intended exercise or general mobility, we need to add this to our basal metabolic rate. So there's the component of physical activity that we call NEAT, another term you should be familiar with, which is our non-exercise activity thermogenesis. So this is when you're sitting at your desk and you feel like you're doing nothing and not burning any calories. In fact, we are burning calories during that because we have to have muscles firing to keep us upright and not in a pile on the floor. So all of these pieces go into the calculation of total energy expenditure. And then, how do we calculate the physical activity piece of this? This can be a pretty controversial calculation, I suppose, because as always, when people give us numbers, they vary from source to source. But in general, we will take our basal metabolic rate and multiply it by a certain factor dependent on the activity level. So someone who is sedentary will have a lower factor to multiply by than someone who is particularly active. Again, you'll see a vast difference in the actual figures provided. What I recommend is that you get a perspective of what sort of factor it is, so somewhere between 1 and 2. However, we know that there are extreme athletes, people that are riding century rides, ultra marathoners might run 50 miles in a day. They are certainly going to be above the extremely active level. So you might even see numbers towards 3. So don't go memorizing the numbers, just sort of get a relative idea that physical activity is multiplying the basal metabolic rate by a particular factor.